Welcome to Unit 3 on two-variable statistics. This is Lesson 3, Associations in Categorical Data. Our learning goal today is to look for relationships between categorical variables. We have one learning target. By the end of this lesson, you should feel comfortable making the statement, I can look for patterns in two-way tables and relative frequency tables to see if there is a possible association between two variables. We have 5 glossary terms. Number 1, association. In statistics, we say that there is an association between two variables if the two variables are statistically related to each other. If the value of one of the variables can be used to estimate the value of the other. Number 2, categorical variable. A variable that takes on values which can be divided into groups or categories. For example, color is a categorical variable which can take on the values red, blue, green, etc. Number 3, relative frequency table. A version of a two-way table in which the value in each cell is divided by the total number of responses in the entire table or by the total number of responses in a row or a column. The table illustrates the first type for the relationship between the condition of a textbook and its price for 120 of the books at a college bookstore. Number 4, two-way table. A way of organizing data from two categorical variables in order to investigate the association between them. And our 5th glossary term for this lesson, variable in statistics. A characteristic of individuals in a population that can take on different values. Now we can begin the practice problems for Lesson 3. Our first practice problem asks, which value would best fit in the missing cell to suggest there is no evidence of an association between the variables? So when they want no evidence of an association, no association means the change in variables doesn't change the likelihood of the outcome. What this means is that we want to see the same likelihood whether it displays the date or it doesn't display the date, whether it's a digital watch or an analog watch. What I'll notice first is that there are twice as many digital watches that display the date as there are analog watches that display the date. So if there's no evidence of an association, then we should see the same likelihood. I should see twice as many digital watches not displaying the date as I do analog watches not displaying the date. So if 54 divided by 2 equals 27, then 18 divided by 2 equals 9. And that would match answer choice A. You can also look at this when we flip which categories we're looking at. I can see that digital watches are 3 times more likely to display the date than not display the date. So 54 divided by 3 equals 18. Well, if I don't want an association, then my analog watches should be 3 times as likely to display the date as they are to not display the date also. And when we try that, 27 divided by 3 also equals 9. So if we put 9 into that missing block, then we see no evidence of an association between the variables, because it doesn't matter when the variable changes. You are twice as likely to have a digital watch as an analog watch, whether it's displaying the date or not, and you are 3 times as likely, whether you have a digital watch or an analog watch, to display the date or not. So the change in the variable is not resulting in a change of the likelihood of an outcome. If you have any questions about how to solve a practice problem such as this, please use class time to ask for further clarification now before we move on to the next practice problem. Our next practice problem says the relative frequency table shows the percentage of each type of art, painting, or sculpture in a museum that would classify in the different styles, modern or classical. Based on these percentages, is there evidence to suggest an association between the variables? Explain your reasoning. So, first, we want to pay attention that it shows percentage of each type of art, painting, or sculpture. So we are looking at the rows. Notice that when we add the rows together, that's when we find our 100%. So, if we want to know whether there is an association between the variables or not, if we change the category from paintings to sculptures, do we see a significant change in the likelihood? Well, changing from paintings to sculptures only results in a 3% difference. We see it go from 41% chance of being modern if it's a painting down to a 38% chance of it being modern if it's a sculpture. We see it change from a 59% of being classical if it's a painting up to a 62% chance of it being classical if it's a sculpture. A 3% difference is not significant. So we would say there is no association. It is a little bit subjective. Different people can have different opinions on how much of a difference there needs to be for it to be significant or not significant to determine whether there is an association or not. But most people would not see a 3% change as a significant difference. So it does not appear there is an association between the variables. You are almost just as likely to have it be modern or classical, whether you're talking about the paintings or you're talking about the sculptures. If you have any questions about how to solve a practice problem like this, please use class time now to ask for further clarification before we move forward. Our last practice problem: an automobile dealership keeps track of the number of cars and trucks they have for sale, as well as whether they are new or used. Based on the data, does there appear to be an association between the type of automobile and whether it is new or used? Explain your reasoning. So, because it says between the type of automobile and whether it is new or used, I'm going to look at the likelihood that a car is new or used versus the likelihood that a truck is new or used. So when I add these together, 812 plus 422 equals 1,234 cars. And when I add the trucks together, 233 plus 51 is 284 trucks. So, new car is 812 divided by 1,234 times 100% equals the 8 tells us to round the 5 up to a 6. So it is a 66% chance that if you have a car, it is new. Used car equals 422 divided by 1,234 times 100%. The 1 tells us to round the 4 back to itself, so it is a 34% chance that if you have a car, it is used. So now we're going to look at the truck. If the percentages come out similar, then there would not seem to be an association. But if we see a big change in those percentages, then there would seem to be an association between whether it's a car or a truck and whether it's new or used. So, new truck is 233 divided by 284 times 100%. This gives us an 82% chance that if it's a truck, it's going to be new. And finally, when we look at used truck, that's 51 divided by 284 times 100%. The 9 tells us to round this up to 18%. So if we look, you are 16% more likely to have a new truck than a new car. And you are 16% more likely to have a used car than a used truck. That is a 16% difference. When you change from car to truck. This shows there appears to be an association. Between the type of automobile and whether it's new or used. So overall, in this lesson, what we are trying to see is that when I change one category and it doesn't seem to change the other category very much, then we would say there does not appear to be an association, because you're just as likely to get your results even when you change between categories. But when you see a situation like this problem here, if I change the categories and all of a sudden I see a significant change in the other categories, meaning the likelihood that I'm going to get my second category seems to be affected by which of the first categories I pick, that's when we say there does appear to be an association between the two. So if you have any questions about any of the practice problems that we went over in this lesson, if you have any questions about how to determine whether there appears to be an association or whether there does not appear to be an association, please use class time to ask for further clarification before we move forward to lesson 4.